Good day, everybody. Remember all the announcements over here on the left side of me. Remember, there's a PC later this week. It'll probably just be a take-home code because I know a lot of y'all have those AP tests and all that. So good luck with that. But we got a couple more videos to go through. Today, we're going to continue with multiplying and dividing, and we should be feeling good with it, right? All right, so let's go ahead and start with a warm-up. We're going to do now real quick. Make sure you get a piece of paper for notes and also get a calculator. Notes also I provide up there if you want to get a printout of that. That is yours to get and use. But let's get started. So this is going back to working with exponents. All right, you probably learned this in 8th grade, but let's do a quick review with it. Remember when we're adding exponents together, you can only add the like terms. So in this case, I have x squared, 7x squared, and minus x squared are the like terms, so I can only combine those. So my answer here should be 7x squared minus x squared plus 3x. Again, I'm going to subtract those, so now I got 6x squared plus 3x. All right, let's go to this next one. Now we got multiplying exponents. Remember when we were multiplying exponents, if I did something like x times x, those are technically to the 1 power. And what you do when you multiply them, you just add them together, right? You count how many x's you have to the 2nd power in this case. But let's do number 2. And again, when we're multiplying, we only care about the coefficients as well. We can't combine those x's together. So I'm going to write this separately as negative 2 times 5 times negative 8 multiplied by all your x values of x to the 3rd times x to the 4th. Simplify that, you should get, I got to use my calculator. So negative 2 times 5 times negative 8. That gives me 80 times x to the 3rd times x to the 4th. Again, add those up. You should get x to the 8th power. That is your answer for that one. All right, last one. So this is those two concepts combined. First thing, we got to do those parentheses. So here I have, can only times these two together, and 9 and 3. So I get negative 12 times x to the 7th power plus 27 times x to the 7th power. All right, so you can combine those, but remember you can only do the coefficients. X to the 7th stays the same because those are the type of x values you have with you right there. So then we get negative 12 plus 27. That should give me 15x to the 7th power. And that's your answer for that. All right, can we do one more warm-up with this? So go ahead and pause if you can and do these on your own. If not, I'll just keep on doing these and you can compare your answers. Okay, again, like terms. For A, we only have two types of things. We got A's and B's, and within those we have our own separate things, right? So understand that A squared is different from B, and B squared is different from all of those, right? So combine your like terms. That should give me 2a squared plus b squared plus 2b. It looks like a 29. I want an a squared, right? Remember, we have to order from the highest degree to the lowest, right? The lowest being numbers. In this case, it would be b. All right, let's keep going. So if I'm going to times these two, I'm going to combine the things that are the same. So this first part, I have the 3 and 5. So that's going to be clearly 15 because 3 times 5. And then that'll be a to the 5th because a to the 4th times a is a to the 5th. And then b to the 3rd. And that subtracts. Again, here, technically there is a 1 in front of that. So 1 times 9 should just give me 9. And then I don't have any other a to the a's, so I'm just going to say a to the 5th times b to the 3rd. Notice how those two now are the same type. Okay, these right here, those are the same type. The type is a to the 5th, b to the 3rd. All right, so I can subtract those. I should have, in this case, 15 minus 9, which gives me 6a to the 5th, b to the third. And that's my answer for that. All right, last one. Man, this is kind of trippy, right? So many letters. I know letters always tripped me out when I was learning math back in the day. But again, you can combine your coefficients. Well, you have 4 times 2 is 8. And then you times your exponents that you can, the same type, right? So x times x to the fourth is x to the fifth. And then y, 7th times y is y to the 8th. Minus, we got here negative 40 with x to the fifth, y to the 8th. All right, we're almost done. So remember we have the minus minus makes a plus, x to the fifth, y to the 8th. And now I can combine those, right? Because those are the same type. So I got 48, x to the fifth, y to the 8th. All right. You'll see a lot of these exponential stuff in 10th grade math. Guarantee it. Gets crazier. But let's get into the lesson today. We're going to continue with multiplying and dividing. You should be able to be comfortable with these composition of functions. Last week we did adding and subtracting and a little bit of multiplying and dividing. But now I'm going to start focusing on values without an x number, right? I'm not going to give you an x. I'm just going to have a general x variable. So let's build some ideas. We're using the table method, all right? The table method is the same thing as a Punnett. I don't know this word. Punnett? I don't know. I just know you do it in biology. It's the same thing as a Punnett square method, all right? So remember how you have those A, little a, big A, those traits, those genes, right? This is going to be the same idea. All right. So what I need to do is if I have something like 2 times x plus 3, well, we learned in the past about just distributing that, right? We times that through, you get 2x plus 6. Easy enough. But really, if we're using this table method, what's going on is I'm going to take 2 as I'm going to make a square of this. That's going to be a 1 by 2, or I guess a rectangle, right? Where I have my 2, my coefficient, I'm going to put right there. And then on top of that, I'm going to have x plus 3. And what we're doing is we're going to multiply these together, right? Just like distributing, we're going to multiply those two together. So really what I get is 2 times x and 2 times 3, right? You go row times column, kind of like with matrices. That's exactly like matrices. So that should give us 2x plus 6. And then that's my answer, right? Obviously, this is an easy example of these ideas, right? But this will get a lot more complicated and we can go from there as well. So let's go ahead and keep going with this. We got a 3x, then on top we got 2x plus 4. So we're going to have a 1 by 2 rectangle. So now I'm going to times those two together. I'm going to times all those together, right? And I should get 3x times 2x. Sorry, let me write this better. Now there. We get 3x times 2x. And we get 3x times 4. That gives me, it looks like 6x squared plus 12x. That's my answer. Same thing in the bottom. Now I got 3 terms. So I'm going to create 3 different rectangles within this bigger rectangle. 1, 2, 3. Yeah, that should work. So I got x on the left side. On the top, we get x squared plus 3x plus 2. So this is a 1 by 3, right? Rows and columns. So then this is x times x squared, x times 3x, x times 2. Simplifies to x to the third power plus 3x squared plus 2x. Pretty smooth, right? Slick Rick. So let's make it harder and use our composition of functions. Let's say I have f of x and g of x. All right. So I want to say we can use this table method for timesing. Dividing, it's going to be a little bit different, but we can go through that in a bit. So again, I'm going to do f times g of x. So this just means f of x times g of x, which translates to We got a big old problem here. We have 3x squared plus 9x plus 6 times 3x. So this, think of this as your row times column, right? Your row times column, the same idea, where this could be your row and this could be your column. I'm glad we did matrices because this is really helpful. So in this case, I have three terms and then one column. So I'm going to have a 3x squared, 9x, and a 6. So this is a 3. This is a 3 by 1. So 3 by 1. Okay, so we got 3x squared times 3x, 9x times 3x, 6 times 3x. This all equals, well, we got 9x to the 9th power plus 27x squared plus 18x. All right, that's our answer. Okay, again, this is pretty much matrices. Kind of crazy. Kind of. All right, same thing goes with this. If I was to write this out, I'd take the top, divide by the bottom, right? So I got f of g, which is going to be 3x squared plus 9x plus 6. We're dividing that all by 3x. Whoops, I'll do that in blue. So basically what we're doing is we're going to break this into pieces, okay? So this x, this 3x in the bottom, in the denominator, we're going to take that and put it into these other pieces. Right? It's the same thing as our normal division rules, right? When you break apart a bunch of terms together, they come individual terms with its respective denominator. So what I mean by that is this turns into 3x squared divided by 3x plus 9x divided by 3x as well, plus 6 divided by 3x. Okay, now this is just algebra now where we start to simplify things. And I know that if I look at the first term, well, 3's cancel out and one of the x's cancel out. So I'm left with x. Plus, looking at 9 divided by 3, well, that turns into 3, and then the x's cancel out, plus 3. Plus, I can't do anything with that 6 and 3, but I do know it can divide out into 2. So we get x plus 3 plus 2 over x. And that's our simplified form. Man, that's going to be 10th grade math, 100%. All right, let's try another one. This one's a lot easier example, I think, but this builds on a concept called completing or factoring or using a FOIL method that you'll learn in 10th grade math. But let's get to it. Okay, so looking at this obviously will turn into f times g of x turns into x plus 1 times x plus 2. All right, well, to do that, you need to understand that this right here is your row, and then this right here is your column, right? So I should have a 2 by 2, I should have a 2 by 2 multiplication thing. I don't know what to call it. Call it the thingy. That sounds good. So I got x plus 2, x plus 1, x plus 2, right? I multiply them through. I get x times x, and I get 2 times x, and then 1 times x, and then 1 times 2. So the idea here, class, is because we have 2 rows and 2 columns, basically when you simplify this, you add them all up, right? You take the sum of all of these, okay? Or in this case, we see that we have 2 x's there, so I'm going to add up the sums of those two. I'm going to add those up. I'm going to add them. Okay, but when you simplify this, you're just taking all those together and just adding them all up. So I get x squared plus 2x plus 1x plus 2, which translates to x squared plus 3x plus 2. All right, you got this. So it looks like I got 4 more examples. Man, yeah, 4 more examples plus 1 hard one. Go ahead and try this. Pause this video, try it yourself. I'm going to just pause mine as well and just show you the answer to make this video shorter. All right, so again, pause this video and go ahead and try this yourself. Okay, this is what I got. So over here, I created a 2 by 2. I got 2x plus 3 times x minus 2. Notice how you have 2x times x, 2x times minus 2. Make sure you pay attention to the negative. Again, what I did here when I simplified everything, I added all the numbers together, I combined everything, and I was left up with 2x squared minus 4x plus 3x minus 6, which simplifies to 2x squared minus 1x minus 6. All right, go ahead and try one more. Check those negatives. I'm going to run this through, but please pause this and try it now. Hopefully you paused. And again, if I was to break this down, I have that x minus 3 times negative 3x plus 3. I know negatives makes things a little bit harder, so I'm just going to break this down a little more. So I got x minus 3 there. I got negative 3x and then positive 3 right there, right? This creates this kind of square. I want to make this a bigger square. Yeah, that works. And there. So that gives me x times negative 3x, x times 3, negative 3 times negative 3x, that's not good, times negative 3x, then negative 3 times 3. That gives me negative 3x squared plus 3x plus 9x, right? Because again, we have here negative times a negative, which gives you positive 9x, doesn't it? And then plus, I guess you say minus 9 because of this other part. This right here is minus 9. Okay, simplify those, combine the like terms, you end up with the answer of negative 3x squared plus 12x minus 9. Pretty good. All right, let's try 2 more. How about that? So this is crazy now, right? We got a hard one here, but I want you to be comfortable with this. This is kind of where you're getting at when we're getting the realms of maybe math 2, but definitely college algebra. I remember I took college algebra, and this is something you for sure do, except it gets a little bit crazier with college algebra, of course, because it's college class. But no worries, class, I got your back. So we can break this down. Hold on, let me just check something. Yeah. That's 4x to the fourth minus 8x to the third power, and then minus 6x squared times negative 2x squared, right? So I can do the table method. This might take a while if you wanted to, but in reality, what I could do is instead, because I just have this negative 2x over here, this negative 2x where I'm pointing at, squared, what I can do is I can distribute that. So I can times that throughout each one of those terms. Okay? Maybe that'd be easier to distribute it. So in reality, what I have is, I'll do this in red. I'll say I have I'll do this in colors, negative 2x squared times 4x to the fourth. Let's say minus 2x squared. Trying to get all these grouped up. It's hard though, isn't it? Let's do this. So I'll say plus negative 2x squared. Basically, I'm just timesing it, but I'm trying to write it in a clean way that you can follow. And I'm taking all those values, timesing them to each other. Times negative 6x squared. All right. Kind of crazy, but we got this. This simplifies into negative 8x to the 6th power plus negative times negative is a positive 16x to the 5th power. Again, negative times a negative, which is positive 12x to the 4th power. That is your answer. Not too bad, just a crazy amount of numbers, isn't it? Okay. What happens if we divide it? Well, it's going to be the same idea as before. Again, I have 4x to the 4th minus 8x to the 3rd minus 6x squared divided by negative 2x squared. Again, you break it into its own separate parts, where you have 4x to the fourth over negative x squared. Let's just say plus over negative 2x squared. Man, I'm just getting flashbacks with dividing all this. There's a thing called long division that you'll learn in next year. It takes a long time, not gonna lie. I know, gross, right? Okay, let's look at each term. So if I was to look at this first one, I know that this 4 divided by negative 2 gives me negative 2. And then if I was to cancel these out, I got x to the fourth over x squared. Side note, when we're dividing, so if I did x to the fourth over x squared, side note, this is like saying x 4 times, and then x times x for x squared, right? Well, remember, when we're simplifying, when we're dividing things, we can take these groups, and those really turn into 1, don't they? So in essence, they cancel out. Okay, and you're left with x squared there. So again, if I was to solve this, we get negative 2x squared. Okay, because technically this goes away and this goes away into x squared. Same thing with the first one, or the second term. We got here negative 8 divided by negative 2. Those two divided together turn to 4. And then we could take out 2 of those 3 x's, and we're just left with x. So we're left with negative 2x plus 4x. Same thing here. We got negative 6 divided by negative 2 is positive 3. And then those definitely cancel each other out. So we're left with 3. And that is our answer, fam. That's pretty much it. We got one more. I want you to try this. This is the challenge, right? This is my challenge to you. Let's say I'm going to add this on to the question down below. If you get this one, I'm going to check each one of those. If you get it correct, I will give you, 2 extra points. Does that sound worthy? I'll give you 2 extra points plus 2 extra points. I got to remember to do that. And I'll grade that and I'll add it to your score once you're done with these problems, right? So let me go ahead and set it up for you at least. But I want you to try this out. If you can try this and do it, you're awesome. But your setup should be 4x squared minus 9x minus 6 times minus 3x plus 4. Heck, I'll even give you the setup of the box thing. All right. So this is a 3x2, by the way. You can even do it like this. There you go. All right, so there's a setup for you. If you can solve that, put it all together, put it an answer below, I'll give you 2 extra points. How about that? Again, with your discussion question, given you got negative 2x plus 2, you're timesing 3x plus 9. Please answer down below. Do not space. If you space, it's marked wrong. For x squared, remember for x squared, just use caret. This is shift 6. Okay, use that for x squared. Shift 6 and then 2. If you don't do that, then it's probably wrong too, because my computer can't do that. Yours can, but I can't. So what did we learn today? We learned about multiplying, dividing, composition of functions, particularly with higher level exponents. We call those higher order variables. Okay, again, don't remember office hours. Come over Tuesday, Wednesday, Thursday for help. Learning activities up. We got a PC later today, or later this week. Later this week. And that's a wrap. Take care. Bye.